Okay, let's discuss amide naming. So, an amide has a general formula of an R group to a carbon, double bond to an oxygen, and then that carbon goes off to a nitrogen. Now, that nitrogen can go to hydrogens, it can go to other R groups, so you can definitely have R, carbon double bond O, nitrogen to another R group with a hydrogen, or even two other R groups. That'll be your primary versus your secondary. You can even have a tertiary, amide. So we're going to talk for now about the primaries, and then we'll probably work on secondaries. Primary amides have that nitrogen with its hydrogens attached to the same carbon as a double bond oxygen. So if we have something like, if we have this, well, in amide, the carbon that is at the center point of the functional group, double bond of the oxygen into nitrogen, that is always carbon 1. We then have other carbons, we have carbon 2 and we have carbon 3, but carbon 1 is always where the nitrogen and the oxygen come together. And so if I want to name this, well, it is a 3-carbon group, so it is a prop. The carbons are single bonded, it is a propan. And the suffix for an amide is amide. So it is a propan amide. And since it really always has to be at carbon 1, you don't really see numbers on amides. There's not really an option. It's like the aldehyde, it has to be at that position. Now if you have slightly more elaborate amides, well, again, carbon 1, carbon 2, either of these can be carbon 3, and the methyl. This just becomes a 2-methyl prop and amide. And so subgroups don't really change anything. You just name your longest chain, put amide at the end to tell you it's an amide, and any subgroups go out front. Now, let's talk about secondary amides. Go back to this, nitrogen. Let's give it a subgroup. So as before, I've got a 3-carbon chain, carbon 1, carbon 2, carbon 3. Let's actually modify it. Let's make this other one longer. So even though over here I technically have 4 carbons, those carbons that come off the nitrogen but don't touch the double bond oxygen, they are a subgroup. This is a subgroup. The amide always has this be carbon 1. That carbon that touches both the double bond oxygen and the nitrogen, that is always carbon 1, and that carbon is attached to the chain going to the left. So this is a prop and amide, just like up above, but the subgroup, well, if you remember amine subgroups, you told that they were on the nitrogen. That is true in an amide. This is a 4-carbon subgroup on the nitrogen. So the naming says, hey, on the nitrogen is a butyl. Written a little large there because I left too much space. This is an N-butyl propanamide, and there's no space between the butyl and the propanamide. N-butyl propanamide. So even though that carbon chain coming off nitrogen is longer, it does not count because it doesn't include the entire functional group. The nitrogen alone isn't it. It has to be the carbon that has the nitrogen and the double bond oxygen. So our longest carbon chain that does that is propanamide. If you have a tertiary, let's say we have that. Well, that gives us a 1, 2, 3 carbon chain again. So this is a propanamide once more. But now I have 2 methyl subgroups. So they are N dimethyl propanamide. And so amide naming is you name the carbon chain that has the carbon that is under the double bond oxygen and attached to nitrogen. And then anything else coming off the nitrogen is named as a subgroup attached at the nitrogen position. And so your primary, your secondary, your tertiary amides, this is the process for naming.